Greetings, team. My name is Rob Duran. I'm a mentor on the FRC team number 948, and I'm looking to start a project with these XRP kits. This video series is designed to have folks take the kits that they have and design their own functional mechanisms for them in the style of FRC robots. I hope to get through several different mechanisms. The first one that we're going to do is just a slap down intake, but this first video here is really just going to introduce the kit, the parts available, and some of the basic design concepts needed for this platform. So our goal here is going to be to design 2 mounts for an arm using a servo. Although servos aren't a normal FRC part, they are very useful for these XRPs. I've provided, or I've put together this kit of all the basic parts for an XRP, and I'll have the link down below. But basically, you've got all of the loose parts that would come with an XRP kit, or at least the parts that are kind of standardized, and some of the parts that you would end up printing, depending on which one you get. And then we have kind of a put together a little assembly of the basic, like, first XRP robot that you would build. And then all the parts are kind of split up in different categories here. We're going to start with the chassis for our robot, and I'm going to make a copy of this one. I'm going to duplicate it, and because this is we're going to use it, right? One of the core concepts of designing any kind of parts will be to design the parts with some kind of context. So this is going to be our servo mount part, and I want to use this as a starting point. And the way I'm going to do that is I'm going to basically chop this in half to get a nice profile to work off of. I'll use our split command. We'll split our robot in half with our right plane. There you go. Now we can see that we've got a little nubbin there that we don't need, and then we can delete half the robot. Now we have this interesting cutaway view that will provide us with some points to work off of for designing a mount. This rail system here is what the XRP uses to mount all the mechanisms. The core idea is that compliant 3D printed parts can kind of snap into place. So our first sketch we're going to work on in our right plane here will be to design something that will snap onto this rail. Basically, you've got some kind of little circular part that'll pop in the top and the bottom and lock into this position. I really like using offsets for a lot of my parts. So I'm going to offset off one side, and I'm just going to go like 5/1000ths or so. Just leave a tiny gap there. And one of the things pretty common for real parts is that the leaving a little bit of a gap around parts you want to fit together is super important. So we'll go off the side, off the bottom, off the top. Actually, I'm just going to do this in 2 halves. I'm going to leave a construction line for my eventual mirroring of a top and a bottom. So now I can focus on just doing my top. Let's do another offset here. Why not? We'll go pretty fancy with it. 5/1000ths or so. This we can connect these with just an extend it. The old extend and trim routine. Extend and trim. Trim. There you go. Now we want some kind of circle that dips into this recess here. And again, we're going to use some construction lines to find our midpoint. We want this to be fairly symmetrical. So line our center up with that. And I think with this one, we can go tangent to the surface it will contact. We make this circle tangent and then finally connect with another extend here. So that should, again, snap into place, and we have some tolerance for it to do that. And then we can kind of complete this whole thing with just a few more lines, really. Nothing too crazy. And this part we're just going to kind of make up and can be adjusted later. Do a little more trimming. Don't need that, don't need that. And now we can mirror the whole thing. Here's our mirror line. Mirror, 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 mirror. Should fill in. And we have a part. I'm going to name my sketch here. So we have our servo. Ta-da, there it is. And if we extruded this as it is, we ought to notice it fits not a revolve. If we extrude, you can see that it should fit nicely onto that rail. Snaps into place. So that's kind of the first thing you if you're making parts for this, you'll probably do a lot of if you've got rails all the way around. Of course, it's not quite done. We need to be able to mount the servo in there. And I'm going to I'm going to derive a servo that we have just kind of out of laziness because I don't want to go back and forth. So there's my servo. All right, it's in, and that's just literally so I can take measurements off of the servo to be able to complete my sketch here. But the basic profile of our servo mount will be to have a some kind of servo. Let's make that construction. Right, there's the profile we're looking for. It's got like a circular part to it as well that fits here. And for example, we can see our first measurement might be that circle. Like how big of a circle is that? Well, that's 0.472. And again, you can go back to your sketches and define that diameter, 0.472. Ooh, it's already looking kind of like a servo. How wide should it be? Well, we have the tangent here, and then the width of it, of course, we can pull off of the servo itself, and it's in two parts. So we'll get it here, 0.906. Now, keep in mind here, we're just doing a construction because it's providing context for what we want eventually. Now, we can line this up wherever we want, but this isn't the actual part we're going to make because it needs to fit into something. If I make some actual rectangles, for example, these will be real parts. This dotted line here, if we do it lined up, the servos, it's not going to fit. It won't happen. This is again why I like using offsets instead, because I can give that tiny little bit of tolerance for a real actual part to fit into with a little bit of wiggle. So we'll do 1, 2, and 3 off the bottom. This is especially important for 3D printed parts. Whatever you're printing is going to have a little elephant foot, or just the printer tolerances aren't what you want them to be. But so leaving yourself a little bit of room is important. So it'll fit into this kind of little grip shape. And then from here, we can, of course, draw some lines out. That'll have to be wide enough for if you can see, we've got some screw holes for it to sit into. I've also kind of ahead of time, like, measured all of this. I have my own kind of servo diagram. You can, of course, look up your servo that you have and find a diagram for it. They exist. Oh man, I missed. And then we can trim. we're gonna just kind of go quickly through this one. Offset this one over, and this one I wrote that one is 0.185. Of course, this could all be done more efficiently with some mirroring and whatnot, but here we are. And then connect everything up across the top. You'll have a little circle for your screws to hold this in place. That's how they plop in. I like to do, I know it's centered, so I can at least do one line, and then I'm going to even do a center line the other way. Just an easy-ish way to locate the spot for a hole. A lot of FRC design is literally finding where the holes go. That's kind of the hardest part of all of our CAD there. 0.079. I looked up what the actual hole was on my servo. And if you have different servos, you'll have different numbers. That should start to look like a place where that servo could land and fit in nicely. I'm going to scooch this all up a bit. Where this thing sits isn't too important at the moment. You get to kind of decide that. But I'm just going to connect these now with my original part here and here, and that'll fill itself in. We could make it nicer if we wanted to, but we're not getting that crazy with it. Now let's redo our extrude to include that part. There you have it. Now we have a little home for our servo to kind of live. And I'm going to do a real quick sketch here because it doesn't need to be this thick. We could put in some other fancy things, like we can make it fit into the circular part of the servo, but again, we don't need to get that fancy. Now I can just kind of extrude, remove some amount of this. Not all, though. Something. Doesn't matter too much. I'm also considering that this would print like that. But that's it. That's a really basic servo mount. If we go to our assembly, now we can kind of test it out. Where's our assemblies? And ploop in our servo mount and the servo. There's our servo. They have a servo mount, by the way. I forgot to name this, by the way. Shame on me. And then we can make these pretty quickly. Here, right in the middle, but I want to scooch it over. Let's go to the side. Inches. There you go. And then as far as the servo, it will go, let's say, here and here. It's half the fun of adding is finding all your mate connectors. Flip it over. There you go. Boom. Got a servo. I didn't check my my distances here. You can see this is overlapping. So either offset that or let's choose a different location. That one and that one here. Flip it. And flip again. Now we have, there you go. Now that's sitting as it would in the actual robot. Now, what do you do with this one? Well, you can make a little arm for it, and there's servo horn stuff to do, and then there's on the other side, so it's not cantilevered, you put another mount, but that'll be a project for video number 2. But give this a try, and that's basically how to use these parts, how to use context, how to use some basic design to make a servo mount. Have fun.